In regards to gamma emission, it's very important to understand what even is radioactivity. Radioactivity is the spontaneous release of energy from the nucleus to an unstable atom. This energy is emitted in the form of radiation. When you see emitted, think of the word lost. It's the opposite of absorbed. Unstable nuclei undergo radioactivity to achieve a more stable configuration. They do this by either number one, releasing particles through alpha, beta, right? So we discussed a while ago, beta decay, and we'll see it again here, and releasing energy in the form of radiation, gamma rays. Why do nuclei become unstable? Atoms are unstable when the number of protons and neutrons in their nucleus isn't in a balanced state. So, for example, if we have too many neutrons compared to our protons, or we have too much energy in the nucleus, or just too few neutrons for stability. By emitting radiation, these unstable nuclei can lose the excess energy of particles and allows them to transform into a more stable configuration. So let's go ahead and look at the different types of the nuclear radiation. So we have here first one of the three main types of radiation is alpha decay. So alpha decay is when an unstable nucleus releases an alpha particle. In this case, there is an additional of two protons and two neutrons. This would decrease the atomic number by 2 and the mass number by 4. So in this case, with alpha decay, you would see atomic number decreases by 2, and then the mass number is decreased by 4. For example, we have here radium. So if you go ahead and look at your periodic table and look for radium, you'd see that radium has an atomic number of 88. It has a mass number here in my example of 226. If it go through alpha decay, it would lose 2 protons, leading to 86 as the atomic number. And then it would lead to 222. Why is that? Because we subtracted 88 to 2, and we subtracted 226 to 4. And it would form a whole different kind of element, since now 86 is different from 88, and that is radon. Remember, every time you change your atomic number, you're changing the element. When you change the protons, you change the atomic number. When you change the atomic number, you change the element. Next, we have beta decay. So we've discussed before beta minus and beta plus decay. I like to think about the fact that these signs are actually misleading. When it comes here to beta decay, beta minus decay, we're actually, instead of minus, we're adding to the atomic number, and beta plus, we're actually subtracting to the atomic number. Why is that? Because in beta minus decay, the neutron turns into a proton, and then in beta plus decay, a proton turns into a neutron. And we've lost a proton, so we subtract 1. And here in beta minus decay, we've gained a proton since a neutron decided to be a proton, and we add 1 to the atomic number. Next, electron capture. A proton captures electron, and both the proton and captured electron turns to a neutron. There is a loss in a proton. So, once again, atomic number subtracted to 1. In gamma emission, however, the nucleus of an atom releases excess energy in the form of gamma rays, not particles. So, because of that, the atomic number and mass number will stay the same, because there's no protons or neutrons that are lost or gained. So, to be more specific, gamma emission occurs when an excited nucleus, so a nucleus that has too much of its energy, releases that energy in the form of gamma rays, which are high energy electromagnetic radiation similar to X-rays but with much higher energy. Remember, no particles are emitted, no nucleus is lost in energy. The identity of the atom does not change. The atomic number and the mass number are the same. So every time you see a gamma emission, think of the fact that the nucleus is not in an excited state. Everything is not changing, not the mass number and not the atomic number. So how does gamma emission work? Gamma emission works in a way to stabilize the nucleus, releasing excess energy in the form of gamma rays, which are high energy photon. And we have here, knowing that no particles are emitted, it's just pure energy. The nucleus returns to a stable state without changing its composition, so protons and neutrons stay the same. And remember that it's important to understand that in gamma emission, it's it's occurring because excited nuclei will often release energy as gamma radiation to move to a more stable energy state. Some nuclei are in a special state called the metastable state, which is denoted by an M after the mass number, and that makes them more likely to undergo gamma emission. So remember, this metastable nuclei are energetically unstable. However, they do not decay through alpha or beta radiation. Instead, they emit gamma radiation to release the excess energy. No particles emitted, energy is released as gamma rays, atomic number and mass number remain the same. And here's a quick summary of what we've discussed today.